Okay. So, hello, mic testing. So now we are going to discuss our lesson for chapter 6. I'm working. So, so be quiet because I'm recording. Okay. So this is chapter 6 entitled The Work and the Kinetic Energy. So you can find this chapter in the University of Physics with Modern Physics with 13th edition with 13th edition. Okay. So you can find a copy of this in the internet. So chapter 6 is about it's about work and kinetic energy. It's about power. It's about doing work. So, but before we go to the discussion of the formal discussion of work and kinetic energy, so we go to the definition of work. So let's first have a review about the scalar product of two vectors, because work is about multiplying two vectors, which is the force and displacements. So these two are vectors. Yung dalawa ay vectors. Kung atin pwede i-multiply yung force at saka yung displacement, makukuha po natin yung vectors. So, so that's why we need to know the scalar product or the dot product of these two vectors. Okay. So if you have vectors, for example, A in this direction, and you have a vector B in that direction with an angle phi between them, okay? So the scalar product or the scalar or the dot product of the two vectors A and B is equal to C. So we can note that the C is a scalar. So it's called scalar product because the product of these two vectors is a scalar. When we say scalar product, it has only magnitude. Okay, so the scalar product of the two vectors A and B is a scalar quantity. So it's C. It can be expressed in terms of magnitude of A and B, magnitude of B, and the angle phi between the two vectors, or in terms of the components of A and B. So dalawa yung formula natin. So we have two formulas. So for example, we have A dot B, AB cosine theta, and we have here the second formula. So we'll discuss that later. Okay. The scalar product is commutative, meaning that it does not matter who comes first. A dot B is equal to B dot A. Okay, the scalar product or the dot product of the two vectors is 0. Okay, kung meron tayong scalar product of perpendicular vectors, so meaning they are perpendicular, so they're 0. So what does this formula mean? So meaning if you have two vectors, A dot B, if you multiply these two vectors, is equal to the thank you. So this is equal to the magnitude of A, which is equal to A, times the magnitude of B. So kung anong magnitude nito, so what is the magnitude of A? So if it is 2 or if it's 3, multiplied by the magnitude of the vector B, determine the magnitude of B, and the cosine phi. The cosine phi, meaning the phi is the angle between A and B. Okay. So however, sometimes vectors is expressed in terms of unit vectors. So what do you mean by unit vectors? Just like this one. For example, unit vectors. We discussed this in chapter 1. If you want to know more about unit vectors, so please review our chapter 1. Okay. Sometimes vectors A is expressed in terms of unit vectors x I hat plus uh, ay j hat plus az k hat. Okay. And vector B, sometimes bx I hat, this is a unit vector form, byj hat plus bzk hat. Okay, so if this is the case, if vectors A and B is in this form, so the product A dot B is just equal to AX, this one, the sum of the product of its components. Okay. AX BX plus AY BY plus AZ BZ. So these are the two formulas. Again, The dot product of two vectors is just equal to the magnitude of A, the magnitude of B, the cosine of the angle between them, or in terms of components, AX, BX plus AY, BY plus AZ, BZ. Okay. So how did we arrive in this formula? So if you know how to derive this one, so we will have a separate video for this. Or you need to read the book personally to know how did we arrive in this formula. Okay. So we have here an example, 1.10, calculating a scalar product. So how do we calculate a scalar product? So in the problem, example 1.10, it says that find the scalar product A dot B of two vectors in figure 1.27. Here, okay, the magnitude of the vectors are 4 and 5. Okay, so meaning the magnitude of these vectors are 4 and 5. So for A, and the magnitude of this is just 4, and the magnitude of this is 5. Okay. So by definition, so we have two formulas. We introduced two formulas about the dot product of two vectors. We have the first formula, A dot B is just equal to the magnitude of A times the magnitude of B cosine of the angle between them. So we already know what is the magnitude of A. We know, we also know the magnitude of B. However, we don't know what is the angle between A and B. So we have here A and B. So we need first to determine angle phi. So what is the angle phi? So can you see? Can you analyze what is the angle phi? Okay. So here, so the angle of A is 53 from the positive x-axis is 53. And the angle of B from the positive x-axis is 130 degrees. So meaning theta is just equal to 130 degrees minus 53 degrees. Okay. Which uh, this is equal to 77.0 degrees. Okay. So so let's put 0 here for the significant figures. Okay. So now we know the angle phi between two vectors. We can now answer the question, what is the scalar product with the dot product of these two vectors A and B. Okay. So here we have here A dot B is just equal to A, which is 4 times 5 cosine of 77.0 degrees. Okay. So if we try this in our calculator, what would be our answer? Okay. So we have 4 times 5 cosine 77. So we have 4 point. So our calculator will give us 4 point. So we have three significant figures, 4 point, uh, 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 4.5. So it's 4.50. So 4.990. So given that we need three significant figures, so this is actually 4.5. Okay. So the dot product of these two vectors is equal to 4.5, or 4.50 in terms of three significant figures. So we already used the first definition of the dot product of two vectors. Now let's go to the second example, which is the example 1.11. So here, our vectors are in unit vector form. Again, if you miss the discussion of our unit vectors, please go back to chapter 1, study and review about the unit vectors. Okay, what are the unit vectors form? So we have a separate video for that, chapter 1. So please uh go back and see our video for chapter 1. Okay. So we have our formula. So if you recall, we have the second formula. The first is A dot B is just equal to AB cosine of phi. Okay. And here is the angle between A and B. And we have the second formula, A dot B is equal to the sum of the component, the sum of its components, the sum of the product of its components, AY, BY plus AZ, okay, BZ. So those are the formulas. Here, we are asked to find the angle between. So given the two vectors, unit vectors, you need to find the angle. So the target variable here is phi. Okay. So the target variable here is phi. Okay. How to answer this one? Okay. So from the formula, we have the vector A that B, okay, is equal to the magnitude of A times the magnitude of B cosine of this one, phi. Okay, since our target variable is this one, so we can divide both sides by the magnitude AB over AB. Okay, therefore, we can cancel this out. Then we have the cosine of phi just equal to A dot B and then over AB. So if we want to find the angle, so the angle is just the cosine -1, okay? So this phi is just equal to cosine -1 A dot B, okay, over AB, okay? So you didn't find the angle. However, we need to find first what is the A dot B and what is the magnitude of A multiplied by the magnitude of B. So if we recall, the magnitude A or the magnitude of our vector A is just equal to the square root of its components, x plus ay squared plus az squared. So the same for b, which is the square root of bx plus by squared plus, okay, bc squared. So first, we need to find a dot b. Okay. So since to get the angle, so we need to find first that a dot b. Okay. So a dot b, okay, this is just equal to ax bx plus ay by plus az bz. So this is just equal to 2 times -4, this one, okay, plus ay, which is this one, 3, okay, 3.00 times 2.00, okay, plus az, this one, which is 1.00 times -1.00. So this is equal to uh, if you use your calculator, this is equal to -3.0. Okay, so let's recheck using our calculator so that we will not make a mistake. Okay, 2 times -4, okay, plus, okay, so wait a minute. So plus, we have 3 times 2 plus 1 times -1. So we have -3. Okay, so we're sure of that. So now we need to find what is the magnitude of A. Okay, what is the magnitude of A? It's just equal to the square root of ax squared, which is 2.0 squared plus 3.0 squared plus 1.0 squared. Okay, so this is equal to, so, so we're gonna use our calculator. Okay, the square root of So we're gonna use our calculator. So the square root of 2 squared plus 3 squared plus 1 squared. So we have the square root of 14. So this is the square root of 14. Okay. Square root of 14 or 3.7. So 3 significant figures, 3.74. Okay. For B, so since we have no space here, so I will write here, okay, I will write here the our B. So let's reposition this one. Okay. So our B is just equal to the square root of B, which is negative 4 point plus by 2.0 squared plus negative 1.00 squared. So our B is equal to the square root the square root of 4 plus plus or square root of 21, or this is 4.58. Okay, so now so we can now get, so since we have now values negative 3 square root of 14, so we can now get the angle theta. Okay, so we can now get the angle theta here. Okay, so the theta is just equal to the cosine negative 1. Okay, so 8, we know the a dot b is just equal to the negative 3. Okay, 3.0 over, we have here the square root of 14. Okay, times the square root of 21. So you can also use these values here, so it's this one or this one. Okay, so we have here the shift cosine. So we have negative 3 and square root of 14. So times, so, so wait a minute. Times square root of 21. So we will have our answer is equal to 100.076, or in 3 significant figures, this is equal to 100 degrees. So if you have two vectors, if you are asked to find the two vectors, okay, if you're asked to find the angle between two vectors given by unit vectors, you're given a unit vector, so your answer would be, your solution would be like this. Okay, so in the next video we will discuss now the work done by a constant force. Okay, so please click and subscribe to our channel for more informations for chapter 6. So thank you everyone for watching.